Now let's look at source transformation. What source transformation says, if I have a voltage source, we'll call it Vs, with the resistor here connected in series to a rest of a circuit. There's more to the circuit to come. I just don't want to draw the rest of it. This is the circuit here. I can take that problem and replace it with a current source. Notice the direction of the voltage, minus the plus. A current source pointing upward with the value of what? Vs over R. In parallel with the same resistor. That resistor doesn't change. The rest of the circuit doesn't change. I'm using Ohm's law. I equals V over R. Or, if I have a current source, we'll call it I sub S, in parallel with the resistor, and this is the rest of the circuit, I can replace it with what? With the voltage source in series with the same resistor, the same circuit here. What's the value of that resistor? Ohm's law, V equals what? I times R. And sometimes when you do that, you can eliminate 3-4 equations from the problem by doing what we call source transformation. Let me start with a simple problem and build on it. Oh. Can't freeze. I forgot the camera's on. Try to freeze here. Here's my example. Nine milliamps. In parallel with 5K. I have a 4.7 ohm, kilo ohm, not ohm, resistor, another 3K resistor, and a voltage source of 3 volts. And the question here, can you tell me what is that current go in that direction? I can do source transformation right here. Notice the arrow is pointing upward. See the current's going upward? That means the plus is on the top, the minus on the bottom. I'm doing source transformation. The value of that source will be this times that. 9 milli times 5K is 45 volts. And that resistor goes on the top with 5K. That's we are right here. Now let's copy the rest of the circuit. Is that 3 or 30? That's 3. And if you want, can you add these resistors together, make it one resistor? I can even add the voltage source, but I'll leave them. 5, that's 9.7. Is that 12.7? And what's this current? Going to the right. I can do KVL here. Sum of the voltage in a closed loop is 0. Negative 15, or 45, not 15. Negative 45 plus 12.7 K times I plus 3 is equal to 0. 12.7 Ki equals what? 42? What is I equal to? 42 divided by 12.7 K. That'll be a milli. 42 divided by 12.7 milliamps. .3 milliamps. 3.1 milliamps. Very popular method, source transformation. Yep, I can combine the two sources, combine the resistors, and that's the whole idea of that actually. Let's try an uglier one. It looks like a tough problem. I have this problem here, 5 amps. Leave a space on the top. There's a little bump there. This is 3K. $4K, 7K. There's a 4K here. There's a 7K down here. There is a dependent source here. Dependent current source, the value, 3Vx. In parallel with that, 17, not K, just 17 ohm. Oh, there are no Ks here. They're all ohms, no Ks. I'm just taking the problem out of the book here. Really doesn't matter, but that's 7. We have 2 ohm. We have 9 ohm. And we have a current source here of 1 amp. And the question is, once I find it, calculate the current through the 2 ohm resistor. What's this current? And now Vx, let me tell you where Vx is. Vx happens to be right there across this one. Let me clean it a little bit there. Vx is right here. And this is the current, I. What I can do right now quickly, I can do source transformation here. I can do source transformation here. I can do source transformation here. All 3 of them. If I do a source transformation, 5 times 3 is what? 15? 15 volt. I'll have 3, 4, 7. If I do source transformation, you notice that's in parallel. It's going to be a voltage source going to the right. It's going to be a dependent source. And what's the value of that? 3Vx times 17 Is that 51? With a 17 ohm resistor in series with it. So we take a current source in parallel with the resistor, replace it with a voltage source in series with the resistor. This is that Vx, the 2 here. This is I going in there this way. This is the 9. Oh, sorry, I changed that to a voltage source, right? What's the value of that? Plus on the top, minus on the bottom. The value of that, 1 times 9, 9 volts. I can do Coulomb source transformation, by the way. See this one here? What's 3 and 4? 7. I get 15 volt source in series with 7 ohm. See that? So I can do a source transformation, make that a current source, value pointing upward, 15 over 7. 7 here, 7 here. I can take the 17 and the 9, put them together. Don't worry if there's a resistor between them. What's 17 and 9? 26 ohm. And this is I still go in that direction. I don't want to combine the 2 with them. Why? Because I will lose Vx, right? But what is Vx equal to in terms of the current? Isn't that 2 times I? 2 times I. Give me a few minutes. Now what about these 2 resistors? How are they connected? That's 3.5. When they equal, it's half of that. So now I can do one more source transformation. $3.5. And the value of that will be what? 15 divided by 7 times 3.5, 7.5. I can combine these guys if I want to. I can leave them alone, no big deal. Either way is fine.
Could have done a source transformation on 9 and 26.
I could, but now it's actually one single mesh here. See how now it's one loop? And if I'm looking for I, I'm in good shape. There's my I. And I can do one mesh equation right now. Sum of the voltage in a closed loop is 0. Negative 7.5 plus 3.5i minus 51 Vx plus 26i plus 2i plus 9 equals 0. Nine minus 7.5, is that 1.5? So negative 1.5 here. 3.5i, 26i, 2i, what's that? 28. 28 and 3, is that 31.5? Minus 51 Vx. And what was Vx? We said Vx equals what? 2i. Plug it in. 31.5i minus 102i (31.5 minus 102), it's negative what? 80.5i equals negative 1.5, and what is I equal to? Is that 0.0186 amp? So the beauty of this method is we can take, if I did KCL or KVL here, there's lots of loops, lots of nodes. By keep doing source transformation, we truncate that to a smaller circuit, and now only have to use one of these.